What if artificial intelligence became smart enough to design new medicines in seconds, or predict the global economy with near-perfect accuracy, or even simulate the universe itself? Sounds like science fiction? Not anymore, because something extraordinary is emerging at the edge of science and computation. Welcome to the strange and powerful world of quantum computing and artificial intelligence, where physics and intelligence collide to shape the future. Now, what does quantum even mean? Before we dive into quantum AI, let's understand the word quantum. It comes from the Latin word quantus, meaning how much. In physics, a quantum is the smallest possible unit of any physical property, like energy or matter. Think of it like the pixel of reality, the tiniest building block you can't divide further. So, quantum mechanics is the science that studies how things behave at the tiniest scales imaginable: atoms, electrons, photons, and beyond. Now you might be wondering, how is quantum physics different from the physics we studied in school? Great question. Classical physics, also called Newtonian physics, deals with things we can see and touch: falling apples, moving cars, swinging pendulums. It's predictable, logical, and works beautifully, until we shrink things down to the size of atoms. At that tiny scale, the rules of the universe start to get weird. That's where quantum physics steps in. In classical physics, a ball can only be in one place at a time. In quantum physics, a particle can be in many places at once until you observe it. In classical physics, flipping a coin gives you heads or tails. In quantum physics, a qubit can be both heads and tails at once until you measure it. It's unpredictable, it's probabilistic, but it's also proven by experiment after experiment. Basically, classical physics is the world of certainty, while quantum physics is the world of possibility. And that's why it's such a game changer for computing. Classical bits versus quantum bits, qubits. Classical computers, the laptops, phones, and even today's AI systems process information using bits. A bit can only be 0 or 1 on or off, like a light switch. But quantum computers use qubits, quantum bits, which behave very differently. Thanks to a phenomenon called superposition, a qubit can be 0, 1, or both at the same time. Imagine spinning a coin in the air, it's both heads and tails until it lands. That's superposition. The magic of quantum entanglement. Here's where it gets weirder, and cooler. In quantum physics, two particles can become entangled, meaning they are deeply connected, so much so that changing one instantly affects the other, no matter how far apart they are. It's like having two magical dice, roll one in New York, and the other instantly shows the same number in Tokyo. Einstein called it spooky action at a distance. Today, we call it quantum entanglement. It sounds unreal, but it's been proven again and again in labs, and it's the backbone of quantum communication and computing. Now, what does this have to do with AI? Glad you asked. Artificial intelligence involves massive amounts of data processing and pattern recognition. From training language models to simulating complex systems, it's heavy-duty math. Classical computers do this sequentially, one calculation at a time. But quantum computers can explore many possibilities in parallel, thanks to superposition and entanglement. That means they could make AI much faster, smarter, and able to solve problems that are impossible today. Real-world possibilities of quantum AI. Let's look at where this combo could take us. 1. Drug. Quantum AI can simulate molecules at an atomic level, unlocking new treatments for cancer, Alzheimer's, and more in days, not years. 2. Logistics and optimization. Airlines, supply chains, traffic systems, all involve complex variables. Quantum AI could find the most efficient routes instantly, saving billions. 3. AI model training. Large language models like ChatGPT take weeks to train. Quantum computing could slash this to minutes, revolutionizing how fast AI evolves. 4. Cybersecurity. Quantum AI could break or rebuild encryption systems, forever changing how we think about online security. While it sounds magical, let's stay grounded. Quantum computers are still experimental. They're highly sensitive, hard to build, and require near zero temperatures to function. Still, progress is real. In 2019, Google's Sycamore processor achieved quantum supremacy, solving a problem in 200 seconds that would take a supercomputer 10,000 years. Companies like IBM, Microsoft, D-Wave, and IonQ are racing to scale quantum systems. Research labs are now exploring quantum-enhanced AI algorithms, like quantum neural networks and quantum support vector machines. The road ahead, what's next? In the next 5 to 10 years, we may see hybrid systems, where classical AI is accelerated using small-scale quantum processors. Eventually, quantum AI could solve climate modeling problems, predict pandemics before outbreaks, enable hyper-personalized medicine, simulate human-like intelligence more accurately. In short, quantum computing might be the turbocharger AI needs to move from smart to revolutionary. Let's recap this quantum journey. 1. Quantum refers to the smallest unit of reality. 2. Qubits can be in multiple states at once, superposition. 3. Entanglement allows particles to stay connected across space. 4. Quantum plus AI equals next-gen intelligence. 5. We're in early stages, but the future looks extraordinary. The intersection of quantum computing and AI could be the biggest leap since the birth of the Internet. It's weird, wonderful, and potentially world-changing. So stay curious, stay inspired, and stay tuned. Thanks for watching AI Awaken, where the future is unfolding, one episode at a time. Like, share and subscribe. Tell us in the comments, what possibility of quantum AI excites you the most? And don't forget to hit the bell icon because we're just getting started.